Hello and welcome. In this lecture, we are going to be learning how to connect up our animations to our gameplay, and we're going to get the speed of our character hooked up to the blend space so that we can get this effect. Let's dive in and see how it's done. Okay, so we have got ourselves a blend space to integrate into this ABP shooter character. First thing I'm going to do is I'm going to go ahead and delete these two blends that we used as an example of how the animation blueprint anim graph works. And instead, we're going to bring in from the asset browser in the bottom right, the blend space that we've just created, this BS_locomotion. If you drag that into your anim graph, you'll see it brings in this little green node here. And very much like the other blend nodes and things like that, we've got ourselves an anim pose that we can drag into our output. And if I hit compile, you can see it's just in our default space. And then you can see this little visualization, which is quite handy, of the little blend space. And we could go ahead and change the values in here statically, or we could input some variables into here. Well, we're probably going to want to do the latter, so I'm going to go ahead and delete the two variables we've got, the left and the forward, because we know now that what we want is an angle, which is going to be a float. So let's change that over to float. And we're going to need a speed variable as well, which is also a float. And we can patch those two in, the speed variable into the speed and the angle into the angle. And we go hit compile, look at our anim preview editor, and just tweak the values. So first of all, the speed, let's bring the speed up a little bit. Let's bring the speed up to about 30. See what happens. There you go. He starts to walk. If I bring it up to 70, he is getting closer to running. I bring it to 100, well, not 10, 100. Then he's full on running. And then we can change the angle. So at 90 degrees, he's going 90 to the right. Minus 90, he's going over to the left. We can go somewhere in between, so we can say 45 degrees. You can see it runs at a 45-degree angle. And you can see the blend space, where it is trying to pick in the blend space and what animations it's sort of blending between. It's blending between that forward animation and that 90 degrees right animation. So that's cool. We've got that going. But as we know, this needs to be driven by our actual gameplay. And why do we do that anyway? Why don't we just have the animations drive our gameplay, saying, you know, we need to be moving forward at such and such a pace? Well, the reason for not doing that, the reason for not using the animation to drive gameplay, is that you often want your designer to be able to tweak all sorts of variables about your gameplay. You want them to be able to say, okay, well, it doesn't feel right that this character is running at this speed. He needs to be running at this speed instead. And walking should be more at this speed. So you don't want your animations to constrain the design and game feel. You want the animations to come off the back of your game feel and make it look good. So during your design process, you might realize, actually, we need a faster running animation, and that's okay, but you want to be able to change up the game first to get there, rather than have to go and try and record a different running animation or find a different running animation and then realize that actually that didn't improve the feel of the game. That's why I want to keep these two things as separate as possible. There are times when things really must line up with the animations, but this is not one of them. So there are exceptions to every rule, so don't take this as a completely set in stone rule. You'll definitely see instances of games that drive some features from the animation, but generally speaking, we want to do it the other way around. We want to say, what's the speed of the character in the game? Let me go and update the speed of the animation, rather than saying, what's the speed of the animation? Let me update the speed of the character in the game. Okay, with that said, how do we do this? Basically, the mechanics of it are that this blueprint, this animation blueprint, has an event graph like other blueprints do, which means that it can have things like a tick event. If I go over into the event graph and have a look, we have got a couple of event nodes in here that we can use to start from. We've got this blueprint update animation. If we come off of this, every time it wants to update the animation, it's going to give us the execution node and allow us to go ahead and grab some state. So what we're going to do is every time this is called, we go and grab some state, and notice here it's got this get pawn owner. That's saying go ahead and get the pawn object. So let's remind ourselves the pawn in this case is a character being a subclass of pawn, and it would be this BP shooter character. Why would it be the BP shooter character? Well, let's see. Because this character, if we select the mesh, go to the viewport, it's currently running just a simple animation, but what we want to do is change the animation mode over to use animation blueprint, and we want to use that ABP shooter character. So that is why this is the pawn owner. It's using that animation blueprint, so the blueprint now has a pawn owner. And so what we want to do in this update function, just to summarize, is we want to grab the information from the pawn about its movement. We want to say, what's your speed? What's the angle of your movement? That's what we're going to calculate. In this lecture, we're just going to do the speed because it's the simplest to do. The angle is going to require a little bit of manipulation with transforms, which we're going to look at in the next lecture. So the node that we're going to want here is to get the velocity of our pawn owner. That gives us this vector here. And then off the back of that vector, we want to find its magnitude or its length. So we can drag off of that vector, search for the magnitude, and notice it's been clever here, and I've searched for magnitude, but it's given me the function called vector length. So clearly magnitude, they've clocked that it's a synonym for vector length. Why do we want to get the vector length rather than the vector itself? Because we're looking for a float, which is the speed. Vectors include the direction as well as the speed, which we're going to need to calculate the angle, but it isn't what we need to calculate the speed. So a little mini challenge for you here. Go ahead, there isn't any other challenge in this lecture. Go ahead and set the speed using this vector length. And remember, if you need any execution pin, we're trying to do this on the blueprint update animation. So pause the video and have a go. Okay, welcome back. So the speed is what we want to set. So if I drag that into the blueprint and hit set speed, you can see we've got an execution pin that we need. We're going to get that from the blueprint update animation. And we need the data pin, which is going to be the speed that comes from our vector length of getting our velocity. So we should be able to go ahead and save and compile that. You can see that's reset the speed to 0 because now it's trying to set it from a pawn owner that is not really there. So what we're going to want to do is actually go ahead and play in the world and see what we've got. Okay, this is much better. We've got ourselves a pawn that's staying static on the ground, except for when I move, at which point it is giving me some speed. And if you use an analog input, such as a controller, you can see that by changing the analog input, that sort of changes the speed, we can change how fast this guy is moving. Now, obviously, there are two problems here. The first one being that if I move off at an angle, it's just using the absolute speed, so it's not adjusting that angle in our blend space, and so the animation looks wrong. The other problem is that we're getting definitely some foot sliding here because the speed of our animation is not matching the speed of the character in our game. That's something that we will look at fixing in a following lecture as well. Great stuff. Hopefully you now understand how animations should hook up to gameplay using the animation blueprint, and you should be able to go and apply that to your own game. See you in the next lecture where we will be hooking up those angles so that this movement looks a bit more natural.